Hi everyone and welcome back. In today's lesson we'll be looking at theorem 7 and here's what it teaches us. The angle between a tangent and a chord is equal to the angle on the circumference of the circle in the opposite segment that is subtended by the same chord. Now wow, this is quite a mouthful, but let me show you how easy it is and what does it mean. We are basically going to look at this angle A1. That's the angle that is formed between this tangent. Now, first of all, what is a tangent? A tangent is a straight line that is drawn that touches a circle only at one place. And that spot is now point A. Okay, so DAE is a tangent because it touches the circle only at point A. Now we are going to learn that angle A1, which is the angle between this tangent and this chord AC, is equal to the angle in the opposite segment on the circumference of a circle. Now that is this angle B. But why? And here comes the important part. Because this angle on the circumference is also subtended by the same chord AC that forms the angle with the tangent. Got it? Now let me look at it from this side. So this angle here that is formed between this tangent and this chord BA is equal to this angle C. Now why? Because this angle C is on the circumference of the circle, and look, this angle is subtended by the same chord that forms the angle with this tangent. Okay, so now in today's theorem we are going to look at why is this angle A1 equal to this angle B, and here's our proof. We are given DE, which is a tangent to circle O at point A. So here is our tangent and it touches the circle at point A. B and C are points on the circumference, and we want to prove that angle A1 is equal to angle B. Now we are going to do a construction like in many of our proofs. So here's the important part. We are going to draw diameter AOF, and we can call this F any letter you want, and I'll show you in a minute. And then we're going to connect F with point C. Now here we go. So here is the point where the tangent touches our circle, and now we have to draw a diameter. So it goes all the way up through the center of the circle to the other side of the circle on the circumference. Then we call this point F. You can call it any letter. So I called it point F, and then I'm going to connect F with point C. Now that's very important because they ask us A1 must be equal to angle B. I'm going to connect F to the other point on the circumference. Got it? If they ask to show that this angle is equal to angle C, then I would have taken this line and I would have connected it to this point B. Okay, so that's the important thing to remember. Now let's start our proof. Now our proof starts with a theorem that you don't know, and I'm going to call that theorem 8, and it's something that you have to learn from this theorem as well. But we are not going to learn how to prove it, you just have to remember it. Well, it says that angle A1 plus angle A2 is equal to 90 degrees. So this angle A1 and this small angle here, A2, is 90 degrees together. Now why? And here's what you have to remember. That the angle between a tangent and a radius, or the angle between a tangent and a diameter, is 90 degrees. Okay, so A1 plus A2 is 90, and we call it tangent perpendicular to radius. And please remember this one, it's our theorem 8. So now we know that this angle is 90. We also know that angle C1 plus angle C2 is equal to 90. Now why is this angle C1 plus angle C2 90 degrees? Because this is an angle on the circumference of a circle. This angle is subtended by the diameter. So this is an angle in a semicircle. So we write that as the reason, angle in semicircle. And now we also know that angle F will be equal to 90 degrees minus angle A2. Now why? Because this angle is 90, this is angle A2, so this will be 90 minus A2 because of the interior angles of this triangle. So we write down interior angles of triangle AFC, there we go. And we also know that angle A1 is equal to 90 degrees minus angle A2. So this angle A1, that is part of our proof, is also 90 minus A2, because if this entire angle is 90 degrees, well then this one will be 90 minus this A2, this small little angle there, right? Okay, awesome. And we call it complementary angles, because two angles that form 90 is complementary angles. Now we know that angle A1 is equal to angle F, because look, we just showed that they are exactly the same. And we also know that angle B will be equal to angle F. Now why is this angle equal to that angle? Look closely, this is on the circumference, this is on the circumference, and both of them are subtended by this chord AC, so we call it angles in the same circle segment. So angles in the same circle segment, and because angle A1 is equal to F and angle B is equal to F, then it means angle A1 is equal to angle B. And we are done. Okay, so now we know that this angle is equal to the opposite angle in the opposite segment that is on the circumference if it's subtended by the same chord. Now we call it angle between tangent and chord, and that is the reason you can use when we get to application. Okay, excellent. I hope you could follow nicely, and now you know theorem 7 and 8, and see you again next time. Bye.